Hello, everyone. Welcome to another episode of the vBrownBag. Jonathan Frappier here with you tonight. I've got the honor of hosting Kenny Garreau, who's going to be talking to us about Docker infrastructure components like networking, security, and storage. Kenny, how's it going?
Good, man. How are you?
Good. You want to give us the 30,000 foot view of what you're going to cover tonight?
I think that we covered some Docker 101 basics in the first episode. The second episode was geared towards clustering, availability, and scheduling with Swarm. And then we're going to follow up on a lot of the security and storage and networking concepts that we covered in the first episode and in the second episode.
Awesome. A few show notes before we get started. If you've got questions, hit us up on @vBrownBag on Twitter. Also, our Latin America and EMEA shows have handles as well, although I'm not watching those tonight. So if you've got a question for Kenny, you can drop it in the Q&A section on GoToMeeting or tweet at vBrownBag or at jfrappier. Our schedules around the world, we've got APAC running sessions. I don't think they've got anything on the schedule right now, but that would typically be every other Thursday. EMEA's every Tuesday, Latin America Thursdays, and the U.S. show here on Wednesday nights, like we're doing right now. Our guest again is Kenny Garreau. You can follow him at Kenny GA on. I don't know if you have a better way to pronounce your Twitter handle.
Kanaga.
Kanaga. Follow him on Twitter. Hit him up if you've got questions, although I don't know, probably won't be paying attention to that. So get your questions in through me. And with that, I am going to make you presenter.
Cool. So can you guys see my screen here?
I can.
Okay, great. So I actually grabbed my work laptop and I've got it next to me. So I'm on Twitter. If you got questions that you want to, lob out there, certainly feel free. So as we mentioned, we're going to cover Docker infrastructure here. It's going to be a little bit deeper of a dive than we did in the 101 session. So we're going to cover some deeper concepts of storage, networking, and security. You'll find that as I go through the presentation, some of the security aspects will be woven directly in with, say, the storage or networking topic that's at hand. So when we get to the end, where we're going to deal with some of the security slides, it'll feel brief, but I think that when we go back and we look at this a second time, we'll say, oh yeah, Kenny covered a lot of the security stuff for networking here and in there and whatnot. Quick bio for anybody that hasn't watched the other episodes. VMware certified design expert. I'm currently working at App Dynamics, so spending a lot of my time talking to folks about Docker infrastructures and how to optimize their applications. So away we go. What I did in the second session when we covered Swarm is I basically took what we talked about after the pod and presented it as, kind of as an after last week's pod slide in here. So the one thing that I really wanted to stress is how fast Docker moves. So even reading between, some of the stuff that I was doing a couple weeks ago and some of the stuff that I'm doing now, some of the stuff has changed. So I actually went back and looked at some old recordings that were out on Pluralsight and realized that, wow, so much has changed about the Swarm infrastructure in just a few months that I always tell folks, like, hey, if you're not sure what the what the single source of truth is, the docs.docker.com is that single source of truth. So if you're ever concerned that hey, look, a year from now somebody's going to watch this video and be like, man, that Kenny guy, he's living in the past because we're doing things this way. That's just what I want to say, is that chances are the most recent video you watch that was filmed the most recently is going to be the one that's most up to date. So just putting that out there. So quick intro on who's the target audience here and then what we're going to be talking about. So we're looking at virtualization gurus, infrastructure admins, tech generalists, people that are just generally interested in technology. If you're a hardcore developer that is doing CDCI and you have been using Docker for 2.5, 3 years, My skill sets and my level that we're going to be addressing here are probably not going to sate your appetite. So what are we going to actually talk about? So we're going to build on that foundational knowledge from the Docker 101, talk a lot about overlays and their role for Docker networking, particularly in swarms. We'll dive a little bit deeper on storage concepts, and then really, as we're going through here again, the intrinsic nature of security should really present itself as far as how we've designed Docker and how we should deploy Docker. So first thing I want to start off with, and I don't know if I hammered it enough in the introduction session, is that when we're running apps and containers, and when we're running containers themselves, what we want to start to, make that equality is that the app is the container and the container is the application. So normally when we've got, like, take a virtual machine, for example, I can shut down that virtual machine and power it back on, and whatever it had on there before, it's gonna have. That type of approach isn't exactly what we want to necessarily use in the container space. We want to start to think of containers as ephemeral, and that's something that I'm going to cover once we get to the storage stuff, but I really wanted to kind of highlight a few things here. So when we're working with what are called Docker files, the Docker file is an instruction set for when I build an image, how should Docker treat and build that image? Meaning, what should it set up as far as exposure to specific processes in the container? So it handles installation configuration of packages, establishing any of my runtime or my environmental variables that I have. So we set up variables that I don't have to keep typing out specific path names and stuff like that. Ultimately, the big thing in the Docker file is to instruct the container what will actually run as a process when we do a Docker run. Typically anything that you see, by the way, capitalized in here is set that way for a reason, mainly because it's either a syntax or it's an actual command. So the Docker file is responsible for what should the image look like. And remember, we run the container from the image. Now the Docker run, and to a limited extent, the Docker file tells the engine how the container's runtime environment should be established. So it's really important to distinguish what parts of the Docker file are doing image-related, commands and setup procedures, and which of them are for the actual container runtime. So hopefully these examples here kind of illustrate that. In the Docker file, when I'm doing the image build, I might be saying, hey, look, I want to put my files in this directory, or I want to install this package. But the Docker run command says, hey, look, I want to expose these ports, or I want to connect to this network. So again, we want to, be able to disseminate between what are my configuration versus my runtime variables. Ultimately, the container's purpose is to run a single app, right? Do one thing, do it well. I'm not going to build a container and run, a typical LAMP stack, right? I'm not going to run Apache, MySQL, and PHP on that same box. Generally, what I want to do when I build that stack is I might build a container for Apache, and then I also build a container for Postgres or MySQL or whatever database technology I'm going to use. The key thing here is when the container exits, the app exits, right? So same concept as a VM. If I power off that VM, anything that was running on it gets shut off. Conversely, when the application exits, that container exits as well. So that's another kind of key thing is, and that's why, we're going to talk about ephemeral data and what types of data I should store and where data should reside within a container. And that's something we'll get into in the storage section. So quick review, I'm going to bomb through these commands and stuff here, but remember that bridge networking was kind of the default network that's going to be established for us, and that's the default network we're going to plug into if I just go onto the command line and issue a Docker run command. remember that we had some other networking stacks available to us for connecting our containers. But by and large, when you are running a standalone type of environment, you'll probably end up running a bridge network like this if you're just testing things out. Now, there are use cases for host as a container. And what we mean by that is I deployed a single Docker engine, Docker host that has, 32 gigs of RAM and, 8 CPUs in it, for example. And I want to run a single container on there. Now, this is, kind of an introductory way to get familiar with containers and not have to deal with a lot of the associated network configuration on the back end. So why would I want to actually do this? So again, it's a good way to get started with apps that I don't necessarily centrally manage. So if I'm not running Mesos or Docker Data Center or something like that, and I just want to run a POC and say, hey, I can, I can run this app in a container. I can containerize that application. It's good for that kind of proof of concept phase that you might be in as a developer. I want to guarantee resources. I want to make sure that nobody's going to step on, anything that I might be concerned about from a resource perspective. Now, we'll see later that control groups kind of handle some of this for us. But again, if you're in that POC phase and you're just kind of trying to prove things out, it's a good way to start out. If my Docker file just maps ports and I just want ease of use out of the box, I might go with host as a container as a deployment method. Alternatively, if I'm in the kind of, again, the R&D or testing phase of Dockerifying my applications, then I may just say, hey, look, I want to start here. One other, reason, simplicity. Keep it simple. It's easier to troubleshoot for certain because what we're doing is, recall that when we do host as container, the host networking stack is now exposed to that container. So there is no more namespace that's being utilized for the network side of things here. It is all pretty much bare metal network performance. So again, if you're super concerned about latency, if you're super concerned about network performance, the host as container model might be something that suits you guys. So transitioning to Swarm, when we want to look at the architecture of how data is transmitted from controllers to workers, from workers to workers, and from container to container, I think this diagram illustrates it pretty well. So we have 3 basic planes of existence for the network in Docker. 2 that are encrypted, 1 that by default is not encrypted, but that I do have the capacity to encrypt if I so desire. So controller to worker is going to be encrypted via TLS, TCP port 2377. That's going to be stuff for Swarm manager operations, leaves, joins, basically making sure that, hey, I want to check in and make sure this, this worker's here, he's there, give me, your container status, off you go. Control plane traffic is between workers on a network. And what I didn't highlight in this diagram is that what if worker 1 and worker 2 have one overlay, and then worker 2, I labeled it worker N, but let's say that's worker 3. What if worker 2 and worker 3 share a different network? Okay, well, they're going to have different control planes now, right? So they'll have a control plane connection for worker 1 to worker 2, and then worker 2 will also have a control plane connection from worker 2 to worker 3. So that's really responsible for failure detection, topology information, convergence, things like that. The VXLAN data plane, that's where our, containers are going to be communicating. So if I'm sending traffic from container A on worker 1 to container B on worker 2, it's going to be traversing that data plane there. So I think that you guys saw this in the original 101 that we did, and it's just kind of the container overlay networking. So I'll skip through kind of the explanations here, but really briefly, we've created our cluster. We have created an overlay network. We create our tiers of applications. So remember that we're not doing Docker run here. We're doing Docker service, right? So in a swarm, I use that Docker service command to instantiate services. I'm not using the Docker run to run an individual container. There's an additional element here, though, that we didn't cover. The Docker Gateway Bridge is responsible for some very specific operations when it comes to networking from the outside world into the overlay, or into my containers, I should say. So let's talk about what those traffic patterns actually look like. So again, the overlay is responsible for that east-west communication between containers that exist on the same overlay. And remember that we can deploy multiple overlays, right? So the example that we gave was, what if I have machines that I need encryption on? So I've got a PCI network that I'm running Docker containers for. And then I've got a non-PCI network that has kind of everything else, in my organization that's been containerized. I can have those two networks exist on the same hosts, but again, I can't hop between them. I can't just say, oh well, this container's on this host, so let me just get access there. Again, that federation, that management, and that control plane is dictated by the swarm, not by me on the Docker command line deciding to try and attach. And that's something that we can probably show an example of a little bit later if we have some time to get on the command line. Is I can't just start running containers. That's the important part, is that I can't do a Docker run and attach a local container to a swarm network. It's got to be part of the swarm for me to do that. And again, the point there is that, again, if I want to run encryption on one network and run encryption and not run encryption on another network, those networks run differently. If I need to have access to the encrypted network and the non-encrypted network, generally what you would want to do is either provide network access to a specific container that has both, or obviously go through your typical routing and security relationships that are going to exist in your physical or your your virtualized network if you're running ACI or NSX. Now the gateway bridge is responsible for that north-south communication. So really what it's responsible for is, if I am a container that is a web server and I need to A, make an API call out to a third party, but then B, also receive calls inbound, I have a network interface that gets connected to my container that contains access to that gateway bridge. The key here is that if I am going out, I'm egressing that gateway bridge, I don't get to go and, again, hop over to another container. If I'm going out that gateway bridge, it means that I am at the point where I need to be governed by my networking rule sets that exist after that. So whatever VLAN I'm attached to, I've got to hit the gateway and I've got to go out, that subnet, etc. So typically that involves hitting some sort of default router that exists beyond the container infrastructure. So it's kind of tricky, but really I think that the thing to stress is that if you're doing communication between the containers on the same network, it's always going to be through the overlay. And if you're going north and south, if you're going out to a container that's on a different overlay network, you will use the gateway bridge to get out that way. So let's talk a little bit about the segmentation that is default configured out of the box. Now we can change some of this stuff, right? So we want to be careful about what we change. By default, we allow container communication on the same network. So A can talk to B, can talk to C, so long as they're on the same overlay. I also permit any traffic from a container on my network to go to the outside world. So clearly that's one area where I might say, hey, I want to restrict access, to, specific hosts or blacklist hosts or things like that. And again, by default, the denial, I can't communicate between two disparate networks. So if I've got, again, the PCI and the non-PCI network, I can't hop between those unless I've got, again, the example there. If I need access to two networks, add that container to both networks. Sorry about that. Thanks, John. The other deny, inbound, right? I am going to deny any inbound traffic. I don't want to just leave everything exposed to the outside world. So this is where we utilize port mapping using the expose command in the Docker file or a runtime flag that we specify in Docker run. So if I say, hey, look, this is a web server that I want to expose to port 80 on the outside world, then, by default, we're not going to allow that unless we explicitly define that here. So when I'm building, this is more key for when I'm building my containers, right? I want to make sure that I'm explicit, because if I build, a new, killer web app and I don't tell the Docker engine that it's running on a specific port, the Docker engine's not going to know that he's running on that port. So this goes to like some of the stuff like automated service discovery that's available within the Docker engine. That's how a lot of this works, right? It's all software defined and it's all right there in the Docker files. But if I don't tell it specifically what is happening, then generally it's not going to happen automatically. And that's when I would say, hey, look, if I say, the expose command is always going to expose port 80, if I don't want to always do that, then I might say to my users, hey, use the Docker run command to expose the port that you want to utilize. And then obviously if I want to expose, if the example we gave before about host network mode, again, if I run in host network mode, I will be exposed to the outside. So one of the things that we had covered before, I'm going to move this just a second. One of the things we covered in I think the last session with Swarm was native service load balancing. So there's some things that are happening here on the back end that we talked about, like discovery, right? So each of the workers acts as a load balancer in and of itself between the containers if it belongs to that swarm. So if I create a service and I publish that service, each of the workers can answer on its VIP or on its individual IP address for those workloads, right? Even if, and an example here is, Nginx. If I don't have an Nginx workload that's running on, that third worker there, and I still left that typo in there. The worker down at the bottom is supposed to be worker 3. Even if I don't have a container loaded there, the discovery mapping service that is available in Docker knows that that's there. So he says, hey, look, I've discovered that these services are running here, and I want to be able to route and load balance, just in the event that if I lose, an external network or something like that. We illustrated that we can use something like an HA proxy or your load balancer of choice to sit in front of these guys and front end that traffic for us. Let's talk about encryption. So what I want to do here is I want to kind of take you through the flow of what happens when we decide that we want to encrypt traffic. So this nice little Docker network create command down here, you'll see this --opt encrypted. All we're doing there is we're saying, hey, look, one of the options that we want to flag for this overlay that I'm creating is that it should be encrypted. Now, again, you remember that, the services are what get attached here. So not individual containers, the service themselves. Swarm's responsible for instantiating the containers that exist as part of that service. So let's say that I've got a box out here, 1111, and he needs to get to 1112. The pathway that we take as we flow through the stack looks a little bit like this. So first, what happens is we get encapsulated by VXLAN. So I'm on, 111 is a container that's running on, Docker host A. So hits the network stack, says, hey, look, run this VXLAN encap. And then after that is when I'm going to get encrypted via IPsec. again, IPsec's running on that is going to encrypt that packet as it egresses or as it travels through the network stack. I hit my egress, so I'm saying I need to go from, you know, this specific Docker host over to Docker host number 2. That's when I hit my physical network and then the ingress of host 2. At that point, IPsec decrypts that packet. I do the decapsulation on my VXLAN packet there, and then I'm presented to the container that's running at 1112. So this is for really foundational knowledge if you have to troubleshoot something, to know that, hey, look, I have to get encapsulated in VXLAN before I get encrypted by IPsec, or I have to hit this specific part of the infrastructure before I get decapsulated on the other side. Quick note on certificates. The certs are used to ensure that we get that right level of security for our control plane and our management plane. Swarm maintains its own PKI. So what we had to do in past versions was kind of set up our own PKI. And, if anybody's actually gone through that process, you know that it's not something that, is just turnkey. So the fact that this is done out of the box for us makes this extremely convenient. Now, for the folks that are out there that are more security minded than I am, keep in mind that the certs are rotated and on a schedule automatically. So we've got cert rotation. It's done automatically. I can certainly initiate that rotation manually. But really, when your security folks come to you and say, hey, tell me about the security features that exist within Docker, this is one of the ones that you should really highlight, is to say, hey, look, you know what, we're doing automatic cert rotation for our Swarm members, and this is something that's really cool. If you want to get into the commands, obviously, the Swarm init command, you can specify certain things about, key rotation schedules and things like that. And then, the Swarm CA command is useful for, taking a look at your tokens that you have and taking a look at the certs that you have. So let's head towards storage. So a quick review. My Docker image, when it boils down to it, it's a compiled set of software. And that's what enables me to run that piece of software as a container. So the image is kind of the compiled endpoint that I'm going to utilize when I want to run an Apache web server or a Node.js web server. The Docker file defines how I build that image, right? So it says, this is how this image is going to be laid out, from the software that we're going to use, the software that we're going to install, the patch level we're going to be at, the directories that I create, things like that. Part of that process involves layers. Now the layers, again, from Docker 101, the layers get constructed and are reusable. So again, if I'm running Ubuntu, I could run Ubuntu as part of, web app A that I've built, and then, my database server, queue. They're an atomic part of the build process, and it's really key for us to understand that, because when it comes to optimizing Docker files and minimizing the amount of layers that we end up creating when we build a Docker file, or when we build a Docker image, I should say, that's really important. When I build a Docker image, if I've got, 10 shell commands that I want to run, I don't want to run 10 lines in my Docker file of this CMD, because it's going to create 10 different layers. So one of the best practices that we always say is try to minimize the amount of layers that you have and collapse common configurations or procedures into one if possible. So if you're gonna, create a bunch of directories and give those directories permissions, and then, specific, write and read rights, then maybe collapse that into a single command. Volumes are used to store persistent data. this is going to be key for any time that you Dockerize a database. So if you want to store persistent data and you want to have machines that will have access to, multiple containers having access to the same data, volumes are what you're going to want to use. That's really going to be the standard going forward. And then repositories. Repositories are where I get my software. Those can be public or they can be private. So those public repositories are going to be out on, say, Docker Hub or on Amazon. And I'm going to be able to pull software directly from there. So I can go on Docker Hub and I can pull HTTPD, or I can pull Node or whatever software it is that I want to work with. Private repositories, local code. This is stuff that's making me money. I am not going to publish this out to GitHub. Or not GitHub, but Docker Hub. Quick review on secrets. So you remember that Docker Engine has this concept of secrets and config files. The idea behind these is, what if I want to always present a specific configuration file to a web server? What if I have the same certificate that I want to present? What if I have to set the same passwords every time for a set of containers that I run? Secrets and configs are the way to do that. So I'm going to kind of go through here and give you some examples and talk about why these might be bad ideas. So again, this here, why is this a bad idea? Well, pretty obvious. Hopefully it's obvious for most of you guys and gals, is that I'm putting the password right in here. So what's the drawback here? Well, if somebody had, if the service that I'm using uses local authentication, I'm gonna pretty quickly have access, and that's not something that I might not want to give to everybody. Another line here. What we're doing here is we're saying, hey, look, I want to echo some connection parameters to a connection.info file that I might have created on my container. This is a bad idea, because what if I don't want to necessarily expose how my infrastructure looks on the back end, right? So when I start exposing internal host names or IP addresses in here, database names, things like that, probably not a good idea. And then finally here, hey, you know what? I'm tired of looking up the password. I'm just going to dump it in the Docker file. Again, goes to the, up at the top, we're dealing with passwd, so we're dealing with local authentication against the operating system. Down here, we're dealing with the, with getting access to the database or whatever other service might be running on that container. So again, generally a bad idea to use a Docker file for this stuff. Generally, you want to use secrets for this stuff. So secrets are extremely powerful for getting really, confidential data into, stuff that I want to keep secret from the rest of the world into my containers. So I want to go through kind of the hierarchy from a logical standpoint. So I'm going to consider the image as kind of the base in this hierarchy. So there's two paths that the image takes, right? So first is the repository. Well, second is actually the repository, but for illustrative purposes here, first. So when I'm working with an image, I am going to do operations like push and pull. When I do a Docker run for the first time on an image, obviously it's doing a pull in the background. But the idea here is that I have private and public repositories. So what I want to do when I'm architecting, kind of my knowledge infrastructure here, or my storage infrastructure, I want to be sure that I'm putting the right stuff into private, I'm putting the right stuff into public. Generally, when we say public, what we mean is I'm going to Docker Hub to download the latest, Docker image for Node.js. And when I'm saying private repository, that doesn't necessarily mean that it's in my private data center. It could still exist out on Docker Hub, but is in a private registry or private repository. So let's take a look at what happens when we're actually going to deploy or run these images. First, we have the concept of the local cache. So the local cache is when I do a Docker run, that image is getting downloaded to my local Docker host. So this differs greatly from our traditional, vSphere environments, right? vSphere, we're either using, hyperconverged infrastructure, so we're using a distributed data store there, or we're using a storage array network, NAS, whether it's a SAN or a NAS, or whether it's iSCSI or, file-based. So there's a big difference there, right? The fact that each guy is going to get a copy of this. The volumes we use, again, persistent data. I want to store the data. I want to keep that data. I'm running a database that's containerized. Again, and remember, if that container exits and that database data was not on, some sort of persistent storage, that data is not coming back. And we want to treat local cache stuff as ephemeral. Configs and secrets, again, these are things that are going to either get instantiated at boot time for pushing out the right configuration for httpd.conf, or making sure that the latest cert is installed on this web server. Finally, you have the concept of remote mounting directly from the container. Now, again, this isn't necessarily a good idea because if few things, right? One, if we think back to the network architecture we looked at before, when I create that overlay and I attach that, if I've created an overlay and I've attached this guy in there, he's going to have to egress that gateway bridge network, right? So I'm going to be getting a lot of connections that are going out through there. Two, I may not, it's easier for me to do that in volumes than it is to try to work around the security of needing, individual connections from individual containers consistently. So usually what I tell folks is, unless you're running, Docker host, container as a host networking stack, that's really the only use case that you would typically see remote mounts for. Generally, you want to try to keep that within volumes. Again, going back to the storage 101 that we did previously, the reason for that is the same reason that vSphere data stores exist. That way I don't have to make a SAN connection from each individual virtual machine. So let's get a little bit more information on layers. So we've kind of handled the physical / logical of the infrastructure. Now let's start to talk about how we craft our Docker files and how we create our images. Because when we're talking with our application folks, when we're talking with our security folks, our storage folks, we want to be credible in that conversation and say, if I'm troubleshooting something and I go and I look at a Docker file, I want to know what it is that I'm looking at. And, once you start working with Docker, you'll get really familiar and you'll say, oh yeah, I understand what's going on here. It's running this command and whatnot. But it's really important to understand what's happening because you can make recommendations to optimize this a little bit further. So if your app guys aren't necessarily concerned about security, but that's your job, then, you're going to want to be, providing input on that. So again, I'm going to really dumb this down because I don't want to create, 8 different layers here just to illustrate the point. So we're just going to say that we've got 2 layers. So HTTPD is the Docker file that I'm looking at here. So this first line says, as I build this image, I'm going to utilize this package. So the Debbie and Jesse package is what we're going to use. So it creates that Debbie and Jesse layer, but builds it. He's read-only at that point in time. Next, what we're doing is we're layering on this, what we're calling the HTTPD layer. Now, ignore the fact that technically this command actually creates 2 layers, but one with the env command and one with the run command. Let's just say for argument that this is 1 layer. What this layer has done is had said, hey, I'm going to create these directories and I'm going to populate them with these permissions and these ownership rights. So now I've got 2 layers in there. When I go to do a Docker run, I create, again, that small writable layer. That writable layer only gets created at runtime. So in the Docker image that we have created here, these 2 layers are read-only, and I don't get a read-write layer until I instantiate that container. And again, the example we use here is to edit, an HTTP file, but it could be as simple as, starting up the process and, logging data to a specific directory or something like that. The thing to remember, ideally, I don't want to store a lot of stuff there. I don't want to store transaction data. I don't want to store, customer data. I want to keep as little in there as possible, that if I lost it, and that's the way that we need to start thinking about containers. I want to build my container so that if I lost the container, I wouldn't lose the value to my business. We're going to switch gears a little bit because labels I couldn't figure out where to put this. The labels become important because it allows us to label the objects within the Docker infrastructure. So it allows me to say that, hey, these Docker engines are out in AWS, and these specific containers should be run from a local data center, and these volumes have this type of data that exists in them. So the idea is that I can start to filter and search through the objects that I have quickly, because what you'll see is as you build your Docker infrastructure, you're going to have lots of images, lots of containers, and hopefully moving forward, lots of Docker engines that are out there running this stuff. So try to start to label things as you're going forward. If you're just doing test dev, or you're figuring out if Docker is going to work for your organization, you probably don't need to start labeling stuff. But if you're going to start out and you're going to say, hey, look, we're invested and we're going to start pushing forward, let's start to label it so that everybody knows what we're talking about here. If you are a person that if you're going to name your encrypted network Mordor, make sure that you create a label somewhere that says, this is encrypted or something like that. So when I start to talk about security, people start to think, oh, firewalls and secure passwords and things like that. I don't necessarily want to cover, how do I firewall a, containerized application, because that's no different than firewalling a regular application that runs on a dedicated virtual machine. What I want to talk about is the security in Docker that enables us to have as much faith in it performing in the enterprise as folks have in vSphere isolating and encapsulating virtual machines, so that I can run hundreds or thousands of virtual machines securely in my infrastructure. So there's two things that kind of make this happen. Kernel namespaces are one, and control groups are another. Control groups, technically, depending on what kernel version you're running, are a namespace type. But for now, what we want to say is there's two responsibilities here, right? The control group is responsible for making sure that container A doesn't walk over container B in terms of resource utilization. It ensures that, I can't access the memory addresses that, on container B that container A is utilizing. So the point here is it's much the same that the encapsulation that we get in vSphere, right? Where, if you follow Mike Foley, he just goes bonkers all the time because he says, VM escape, that's always been the concern. I'm sure the same security folks would say, oh, the control groups and namespaces in Linux. The point here is that there are systems that exist to isolate those processes and here those network and file systems, those stacks that are individually available to those containers or to the namespace. So, in terms of what you should think of the container as, the container is its own namespace. The control group is what handles kind of making sure that, hey, I've reserved, 1.5 gigs of memory for this specific container. So I need to make sure that that is reserved and that nobody else can walk over my resources. So this, if you take anything out of, how does Docker work from an isolation and a security standpoint, namespaces are really the driving force behind this. So again, control groups, tied to resources. Namespaces deals with how do I, make sure that processes are isolated, each container gets a PID1, etc. So talk about secure Docker operations. So we're going to talk about when I'm running my Docker infrastructure, what best practices, what considerations should I take into account on top of any of the existing protocols and policies that I have in place. So primarily, carefully evaluate who needs full control of this infrastructure. You wouldn't give root to everybody. You wouldn't give domain admin to everybody. That's, kind of the lesson here. Don't give root access to everybody to run their own containers. Now, in kind of this new world that we're in where we're figuring out that a lot of teams have shadow IT and that not all of my resources necessarily are running in my private cloud. Maybe I have got a bunch of stuff in Amazon or Azure that I'm just figuring out. From a control, if I'm an infrastructure person, it was I don't want to just let my users provision as many virtual machines as they want and manage them themselves because they'll never clean them up. Kind of the same concept here. We have a little bit more control over things from the engine standpoint because again, if I shut down the app, the container exits. So there's some kind of inherent cleanup that's available there. Whereas, if I just stop an app on a virtual machine, and I don't blow away the virtual machine is going to stay there. Currently, the roadmap for Docker is to not have to use root to run Docker operations. But for now, it requires root, which is why it's really important for us to figure out who needs it and who doesn't. One of the things that we want to think about is, there's a REST API that is responsible for taking input from the Docker CLI, right? So I want to limit access to that, remote access at least. So if I'm going to, open up that remote API to web servers or a management platform, I want to make sure that, it's restricted, make sure it's on a private network, secure network, audited and firewalled if possible. Don't run other stuff on there. Hopefully this doesn't need too much stressing, to everybody, but generally what we're talking about here is I'm not going to run a web server on the Docker host, right? I'm going to containerize that web server and I'm going to stuff it in a container and then I'm going to run it from there. Now, this doesn't include things like, hey, if I need to run like a software agent, anything like that. We're just talking generally don't install a web server on here. Don't install a database server on here. Let Docker be Docker, and that's that. One of the really cool security features, and I probably should have put this in a different slide, but this goes to how Docker actually operates. The namespaces allow us to provide specific capabilities to our containers. So those function on a whitelist model, and generally anybody that's in IT now has heard the whitelist model as your buzzword bingo. So the idea is there. Typically, we're thinking about it from a network standpoint. Whitelist model. I only want to allow access as I delegate it, as opposed to punching holes. So we say, hey, in the Docker file or when I issue the Docker run, I can set flags, right? That might be to present a volume. Typically, the one that everybody's going to get here is, binding a process or binding a service to a network port. Typically, that requires root access to do that. So anybody that has, been a Linux admin has been through the process of trying to start an application and it says, sorry, must be root. We get rid of that in the engine because what we end up doing is we say, hey, look, you know what? We have these specific namespace capabilities that we can expose if you tell me what it is that you need to do. So again, the Docker file. So if I issue that expose stanza in the Docker file, Docker's going to grant some security permissions to that container to bind a port and run it on that specific, bind a service to that port. So I always tell folks, find out what it is that you're doing with the containers. So that way that you're not, when somebody says, I need all these permissions, say, hey, look, what is it that you're really trying to do? Well, I need root because I need to bind, port 80. Well, what if I showed you a different way to do that? That's really what we're talking about here. I want to talk generically about the ecosystem, about and kind of the security that I should think about with Docker. So primarily, where am I getting my images? If I'm going out to Docker Hub, chances are, if I'm pulling them from the public repo in Docker Hub and I'm pulling HTTPD, for example, I can look and I can see that the Apache Foundation are the guys that publish that. If I do a search and I find, Kenny's janky HTTPD daemon, maybe I don't want to run that, So I usually just say, where am I getting these and who's who published this? So the Docker pull command, excuse me, or the Docker run command issues a Docker pull if I don't have that image locally, remember. The Docker load command, if somebody comes into work and says, bro, I got a new USB, with this fat Docker image on it. Probably don't want to do that. Not unless I really know that person. So it's just a, consideration of where am I getting this stuff? Where are my containers going to run? What access do they need in terms of data, right? If, hey, it's super easy for me to spin up a bunch of these, containers in AWS. Well, we've got latency sensitive applications that require access to a database that exists locally within our data center that takes 10 steps to get through to get us access to that database. Might not want to run it might not want to run those in AWS, the web servers that we're talking about. And then the labels help classify and correlate, right? So it allows me to quickly search through and figure out where this guy's running. So similar to the concept of tagging stuff in AWS, right? I'm just going to take a sip of water here. One of the things to always consider, who owns this code? Is it us? Is there something that is sensitive in here? So critical business logic, critical business application logic, industry competitive data, something that's going to, resume generating opportunities if this gets outside the company. The other thing to consider is, my code might be in a secure repository. So when I'm talking about code, I'm not talking about my Docker images. I'm talking about my code. It's the source code that I check into a repository, whether it's in Git, whether it's in VSS, whatever versioning system I'm using to check in my code. What happens if I got my code and it's in a secure and I know it's secure, but what if I build a container and I push it out to a public repo? Well, now I've just taken secure data and push it out to an insecure medium. So I always want to be sure that I've got some sort of audit trail to follow. How did I build this application? And then how did I publish this application and publish that image for the containers? Who built this thing? And that's what we talked about a little bit before about where am I getting my images. So the first, where am I getting it is more about the physical location of the source. This last one is more about how do I know that, Bob at Apache actually built this version of HTTPD and it wasn't, again, Kenny's janky HTTPD daemon. There's something called content trust and code signing. So what that allows us to do is say, I can sign the labels and the image tags for this specific build that I have. That allows me to say and federate that Kenny actually developed this application, signed it. So when John comes out and says, I'm going to make an update to this guy, it's not going to be trusted, right? What this really helps with is, what if it's not signed? What if somebody pushes something out, but it's not signed? If I've enabled something like content trust and I try to pull that image, it's going to give me an error. Same thing if I try to push it. Hey, you enabled content trust. You need to sign this thing before you put it out in the repository. So the resources, check out the docs. The docs are really, honestly, again, I always say that click that link. It tells you how long it's going to take you to read through that. Some of us read faster, some of us read slower, but it's pretty good as far as, skimming through and getting through the content in that amount of time. Pluralsight has some great Docker videos that are out there. Again, the point that I brought up first was if some of those are maybe an hour, or not an hour, but a year and a half old, some of the stuff that we covered here is going to be more up to date than the stuff that's out there. And hopefully the stuff that I'm covering isn't wrong. Participate. There's meetup groups locally. The Docker captains are the folks to follow on Twitter and on social media to find out, what's the latest and greatest from kind of the captains. That's kind of their evangelism team. So, we've covered Docker 101 in the first session. Last session, we covered Swarm. Today, we covered a lot: network, storage, security. Next week, we're going to get into Docker on Windows. Again, I haven't messed around with Docker on Windows too much, so I'm really excited about this session. So, with that, I want to open it up to questions, comments, feedback. Want to hear from you guys.
If there's anyone on the call who wants to be unmuted, just hit the hand raise button and I will unmute your microphone. Going once. Going twice. All right. Q&A window's all clear, Kenny, so I think we're... Yeah, Graham says he's still trying to take it all in. Me and you both, Graham. So no, this is great. Docker networking is one of the areas that I need to brush up on, and I need to figure out how to get work to maybe fund some of that time.
There's a hold on a second here. How do I send a link to everybody out in the session?
You can pop it in the chat. Everyone should see that. You have a chat window?
I do, but it says that it's only going to send to the organizers. So I don't know if you want to stop the recording just because this is spurious. It's just going to be a link that everybody can follow for some really good networking info.
Awesome. Kenny, thanks again. And that's our show for tonight. If you're catching up with this later on iTunes or YouTube, you've got questions for Kenny. Again, that's Kenny, KENNEGA on Twitter, or you can hit us at vBrownBag on Twitter, like it on YouTube. All that neat social media stuff is appreciated. Thanks again, everyone, and also thanks for all the folks who voted for the vBrownBag as the top podcast this year. So thanks to all of our listeners and all of the folks who have presented this last year. And with that, we will see you next week.